Hey guys, Mr. Milton here. Today we're going to look at the isosceles triangle theorem notes. At the end of this video, you should be able to use the isosceles triangle theorem and its converse to solve problems and complete proofs. Okay, an isosceles triangle has exactly two congruent sides. And the isosceles triangle theorem states that if two sides of a triangle are congruent, then the base or the angles across from those sides are also congruent. So, if we look at this triangle here, we see that ST is congruent to UT. Our isosceles triangle theorem will state if ST is congruent to UT, then those angles, the base angles opposite those sides, then angle S is congruent to angle U. Okay, and we see that those are the angles opposite those congruent sides. Okay, in this triangle in particular, angle T is the vertex angle, okay? And the other two angles we would call base angles. Notice that the isosceles triangle theorem is a conditional statement. That's an if-then statement. Learned that in Unit 2. Write the converse of the isosceles triangle theorem. As we look at the isosceles triangle theorem, it says, if two sides of a triangle are congruent, then the angles across from those sides are congruent. So if we were to write that as the converse, we'd say if, and we can just say instead of the angles across from them because it refers to the sides, we can say if the base angles of a triangle are congruent, then the sides across the angles are also congruent. Okay, and that's what our converse would say. And we have the converse of isosceles triangle theorem here, okay? And so that's what we have. Use the converse of the isosceles triangle theorem to write a conditional statement from the diagram. And that's what we just did. So if we have angle P is congruent to angle Q, then we can say PR is congruent to RQ. Maybe I should say QR, okay? And then if we wanted a reason for that, we'd say the converse of isosceles triangle theorem. Okay, so the isosceles triangle theorem says if we have the sides, then the base angles are congruent. The converse says if we have the angles, then the opposite sides are congruent. All right, let's run through a proof here. Okay, so it's plain your proof. Does it make sense to prove triangles congruent here? What do I need to know? So here it says that triangle TRS is an isosceles triangle. They want us to prove that TRS is an isosceles triangle. So how can we do that? All right. So first, as we go through, we can say WV is congruent to WS. So as we look WV, WS, that's given to us. It's already marked. Then it says that angle S is congruent to angle WVS. So as we look at WVS and angle S, well, why would we be able to say that these two are congruent? Well, we can say that those two are congruent because this is an isosceles triangle. And in an isosceles triangle, if we have two pairs of congruent sides, then those base angles are congruent. So this is the iso triangle theorem, isosceles triangle theorem. And that's why we can say that. The next statement, WVS, right here, this angle, is congruent to angle R. Why do we know that? Well, that's a given information. They told us that at the beginning of the problem. See, in pink, they already told us. And so by the transitive property, we can say that angle S is congruent to angle R. Right, because if S is congruent to WVS and WVS is congruent to angle R, then angle S is congruent to angle R. Okay, and so looking at this large triangle here, we have these base angles as being the same. And so TR is congruent to TS because of the converse of Isosceles triangle theorem. Okay, and you see that we can now use converse, the isosceles triangle theorem and the converse of the isosceles triangle theorem in the same problem. One we started with knowing the sides, the sides, and the other we started with knowing the angles. Okay, and so now we can say that triangle TRS is an isosceles triangle, and that's the definition of isosceles triangle. Okay, we've shown that we have a triangle with two congruent sides. So it's isosceles triangle. Okay, so as we look, were we trying to prove that two triangles were congruent? No. What did we need to show? We needed to show that two sides of the triangle TRS were congruent. Okay, and that's what we need to show. So it's a proof, but we weren't proving two triangles congruent. Something a little new for us for this chapter. All right, now we can use that with proofs, but you might also use it. So we could use the isosceles triangle theorem and its converse in proofs, but we can also use it to find values in problems like these. So in these two problems, we're given isosceles triangles, and we're asked to find the variables, or the values of the variables. So here's an isosceles triangle here with both of these sides congruent because of the markings. And so if these are congruent triangles, or congruent sides, then our base angle should be congruent, 65, 65. We can use that information to along with the vertical angles theorem, right? Because vertical angles are congruent, so this is 65 degrees. This is a isosceles triangle, okay? And so this would be 65 degrees because the base angles have to be the same. And then we use our triangle angle sum theorem to say that all triangles add up to 180 degrees. And so 65 plus 65 is 130. 180 minus 130 should give us X. Okay, and so then we find that X in that first problem is 50. 50 degrees. Okay. Number two, as we try to find X, we can use this first triangle. They gave us that this angle is 70 degrees, base angle of an isosceles triangle, so its corresponding base angle is also 70. This indicates that this whole angle is 90 degrees. Since this portion is going to be 70, it means in this other triangle is 20. This other triangle is also an isosceles triangle. Since this is 20, that means that this must be 20. And again, all these angles together add up to 180 degrees. So X plus 20 plus 20 plus 40 equals 180. Solve for X. X in their second problem is 140 degrees. Okay. Next problem. Let's find the values of the variables given that the perimeter of the triangle PRS is 26 centimeters. All right. So in this problem, they tell us that these are both 43 degrees. That means they are congruent. Okay, that's information that we're going to use because that tells us that these two sides are congruent. Okay, and so we really have two equations that we can use with all the information they told us. They've told us that X is congruent to Y plus 3, because there are the sides opposite the congruent base angles. And then they also told us that X plus Y plus 3 plus 3Y equals 26. Okay, so this is the information that they gave us. Now, it's a system of equations because there's two variables and we can't really solve either of the equations by themselves, but hopefully we can see that X is the same as Y plus 3. In the second equation, if I substitute Y plus 3 for X, then this becomes an equation that's solvable because now I only have the variable Y. And so 2y, 5y plus 6 equals 26. That means 5y equals 20, and that means y is 4. And so now I know that y is 4, and x then must be y plus 3, 7. And I can double check to make sure all that works out. It means this would be 12, this would be 7, this would be 7, 14 plus 12 is 26, works out. Okay? All right, a corollary is an idea that follows directly from a proven theorem or postulate, which means if one thing is true, then the next thing has to be true. Okay, and so a triangle is equilateral if and only if it is equiangular. Okay, so as we talked about isosceles triangles and having two sides that are exactly the same, having two angles that are exactly the same, what follows from that is if we have three angles that are the same, then we have to have three sides that are the same. If we have three sides that are the same, then we have to have three angles that are the same as well. And those are equilateral, equal sides, and equiangular, equal angles. Okay, this is a biconditional, meaning it is true in both directions. You remember that from the second chapter. Okay, the conditional and the converse are both true. Okay, so as we use this to find M and N. So in this triangle, we're given an equilateral triangle, right? All three of these sides of our left triangle is marked as congruent, or are marked as congruent. So that must mean that all three of our angles are congruent as well. Well, since triangles add up to 180 and there must be three congruent angles, all these angles must be 60. Okay, since they indicated that this angle was 90 at the beginning of the problem, that must mean that this is going to be 30. Okay, this is 90, 30 plus 90 is 120, which must mean that M is 60. Okay, and so now we found the values of all of our angles based off of this corollary, the equilateral and equal angular corollary, basically. So M was 60 degrees and N was 30. All right, so we talked about the isosceles triangle theorem notes and the converse of the isosceles triangle theorem, and we also talked about the equilateral corollary. Okay, and we're using that to complete proofs and to solve for values in triangles. See ya.